Good day to everyone. Today we are going to discuss our first topic for the subject EnggPhys or Physics for Engineers. So in this topic we are going to discuss all about vectors, and with that let us just have a simple or a brief introduction of what is physics. Since our subject is physics and vectors is studied under this. So basically, or probably you have already known what is physics, and physics is simply defined as a science that would deal with nature and matter. And with this, when we study nature or matter itself, what we do study here is its motion and its interactions, or the interactions of matter and its structure, or the interaction of those inside their matter, its structure. So when we talk about interaction, this would now relate to our forces, energy, and the like. And since we are talking about nature and matter, physics now is distinguished as a fundamental science. Since we are talking about the broad topic of nature, almost all sciences now are based or is related to physics. Okay? And aside from being a fundamental science, physics now is also distinguished as a foundation of engineering. Why? Because in engineering, there are many topics in which, or yes, many topics in engineering that is covered by physics. So what are this? So we have your mechanics, your optics, the study of light. We have your electrical studies. We have your electronics, nuclear engineering, and so on. So basically, being a civil engineer, so as a civil engineering students, civil engineer will be focusing on mechanics, which is the study of forces and its interactions. So if you're an electrical engineer, an electrical engineering students, then aside from having knowledge on mechanics, we also need to know the foundations of electrical currents, which is a part of physics. Okay? And since we have said that physics is a science, we now apply a measurements, or we always measure what we study in physics. And these measurements now that we do in physics would always define the physical characteristics of the matter or of the object. Okay? And these physical characteristics now that are defined through measurements are what we call your physical quantities. So physical quantities, these are now measurements that are used to define your physical characteristics. So when we talk about physical characteristics, this would now include our observable characteristics of an object. So example, we have the size, the length. So how big is it? How long is it? How small? Okay, how heavy it is. So when we define those, we use your physical quantities. So since we are talking now about physical quantities, we can divide or classify your physical quantities into two. So that is now based on the units that we use in defining them. The first one is what we call our fundamental quantities, and we have your derived quantities. Okay. So when we talk about fundamental quantities, these are now physical quantities that are independent of their own. When we say independent, there are no other terms that could define that quantity or that fundamental quality. So what are these fundamental quantities? We have 7. So what are those 7 fundamental or basic quantities? We have your mass, we have your length, we have your time, we have your electric current, amount of substance, we have the temperature, and your luminous intensities. So these 7 now cannot be defined by any terms except their equivalent fundamental quantities such as your meters, your seconds, and your time. Unlike for the derived quantity from the term itself, it is derived now from other terms. And saan natin siya dinederive? We derive it from our fundamental quantities. So basically, derived quantities now is derived or is a combination of the different fundamental quantities. So what are examples of our derived quantities? We have your speed, which is a combination of meters per second. So it's a combination of length and time. So as our force. So the unit for force, or we define force in terms of newtons. So it's a single term, but newtons is basically equivalent to kilogram meter per second squared. So it's now a combination of 3 fundamental quantities. What is that? We have your mass, we have your length, and we have the time. So that's the difference between fundamental and derived quantities. So aside from classifying our physical quantities based on the terms we use to define them, we also have a classification of physical quantities based on their definition, which is, we have now what we call your scalar quantities and our vector quantities. So when we talk about scalar quantities, these are now quantities that would only have a magnitude but no directions. While for vectors, these are now physical quantities, or these are quantities used to define our characteristics all together with its direction. Okay? So, as I have said, for our physical quantities, for scalar quantities, we have the magnitude. So when we talk about the magnitude, that would simply be the value or the amount and your unit. So when I say 3 meters, that's a scalar quantity. It has a value 3 and it has a unit meters. But for vector quantities, they will have now a magnitude and a direction. Okay, so when I say 3 meters down, so it has a value 3, it has a unit meters, it's downwards, so it has a direction. So that's the difference, that's the simple difference between scalar and vector. So scalar, value and unit lang. Vector, there's already a direction. Okay? So for our representation of a vector, normally we represent it by an arrow. And for this, the length now of the arrow will simply represent our magnitude. Okay? And then, kung saan siya nakaturo, yung arrowhead, that is now where the direction is also pointing. Then, the parts of our arrow would now be our tail. Okay? And then we have your head, or we also call this as the tip. So, head, tails, or tip, tails. So, that's the same. Okay? So, for our direction or notation for the direction of vectors, we have several ways of writing or of defining the direction of vectors. This will now include the simple up, down, left, or right. Okay? So, another way is by the axial directions. So, mathematical na siya. Axial. So, we have your positive x, negative x, positive y, negative y. So, we have your Cartesian plane. So, kung 3D naman siya, the directions would now include your positive and negative z axis. And then, we have your geographical directions, which is more commonly used for 2 dimensions. So we have your north, east, west, and south. Okay? So for our directions, so we have here your west, so it's pointing to the left. We have your north going up, east is moving to the right, and we have going down is your south. And when in terms of your actual direction, so in your Cartesian plane, north now is equivalent to your positive y. We have your east as your positive x, west is your negative x, and south is your negative y. Okay? Okay, so to understand further our notation for the directions, or how do we draw our directions for vectors, let's have an example. So let's say we have the direction indicated as 40 degrees north of east. So how are we going to represent this direction? So firstly, we have your Cartesian plane representing our east-west, or your x-axis, and your north-south, or the y-axis. So from here, basically we need to measure 40 degrees. But where are we going to measure? Are we going to measure from the north or from the east? So in this case, it says of east. It means we have to measure it from the east. So 40 degrees from the east going to north. This is now our direction. Okay, so this is now the line of action, or the line of direction. So this simply means it's 40 degrees north of east, or from east going to north. Or this direction now could also be written as east 40 degrees north. So east 40 degrees north. Or this could also be written using its complementary. So we have now 50 degrees. So where did I measure 50 degrees? I started it from the north. So this could also be written as 50 degrees east of north. Okay? So kung saan yung off, doon nag-start. Okay? Or again, this can be written as north. So north 50 degrees east. Okay? So, pag may off, doon nag-umpisa. Pag walang off, kung ano yung una, doon tayo mag-uumpisa ng measurement. So, aside from that, using north of east, or this notation, we could also write our direction in terms of a single basis, which is our 0 degrees, or the east. Or that is now 50 degrees, or that is now 40 degrees from the east. Okay? And it's measured counterclockwise, since our measurement of angles is always counterclockwise. So 0, 50 degrees. Okay? So if it's stated 50 degrees, it means it's from the east, unless stated in the problem. Okay? Another example, let's say we have 65 degrees west of south. So, anong ibig sabihin nun? So, of south, meaning I'll be starting measuring 65 degrees from the south. So, it will now be 65 degrees going to west. So, this is now our line of action for this direction. Or, if we're going to rewrite it, equivalent directions would include south 65 degrees west, okay? Or, it's complementary. We have 25 degrees. So, that will now be 25 degrees south of west. And we have west 25 south. Or from the east, that will now be 90, 180 plus 25, so that's 205 degrees. Okay, that's for our notation, how we draw or measure later on your directions. Okay, so now we have learned how to draw and represent our vectors. Another important thing to learn in vectors is to identify the difference between collinear, coplanar, and concurrent. So when we say collinear, or the vectors are collinear, it means that they are lying on the same line. Okay, so they are parallel as much as possible. So to understand this, let's see, we have here vector A, vector B, C, vector D, vector E, F, and G. Okay, so which of these vectors now are considered collinear? So when we say collinear, so same line, meaning parallel sila. So we have now vector A. So what are the vectors collinear to vector A? That will now be vector C and F. They are all along the horizontal. Okay? And then we have vector G. So which is collinear to vector G? That would now be vector D. So they are both along the vertical. Then next, for B, it is now collinear with vector E. So as you can see, it's not necessary that the vectors should be pointing on the same direction in order for us to say that is collinear. As long as it's lying on the same line, no matter what the direction is, they are considered collinear. Okay? So next one, we have our coplanar vectors. So when we say coplanar, so from the word plane and co, meaning they are now lying on the same plane. So when we talk about plane, we have your xy plane, your xz plane, and your yz plane. Okay? So, para yan pag kunwari, sa wall, may mga picture frames tayo, may clock na nakasabit sa wall ninyo. If they are lying or they are hung on the same wall, those picture frames are coplanar. Okay? Pero kunwari, yung isang picture frame nyo, nasa kaliwa, yung isang picture frame ninyo, nandun sa may kabilang side, then it is non-coplanar. Okay? So, they are on the same plane or nasa same wall sila dapat. Okay? So, to understand this, let's have our planes. So we have here your x to y plane, we have your yz plane, and we have your zx or xz plane. So let's have vector A, vector B, vector C, vector D, vector E. So which of the following vectors now are coplanar? So we also have here vector F. So which of them are coplanar? So we have AB, they are both lying on plane x, y. And then we have vector CD, they are lying on plane YZ. And we have vector EF lying on plane XZ. Okay? So, basically, mas malalaman natin tong or ma-identify natin kung coplanar sila depending on our direction. So, for example, we have northeast, east-north. So, they are coplanar. Okay, nasa XY plane lang sila. So next we have concurrent vectors. So when we say vectors are concurrent, it would mean that they would lie on, so current point or current position, or they will be lying on the same point, or they would pass through a common point. Okay? So to understand this, let's have these examples. So we have several vectors here. So let's identify which of them are concurrent. So basically, we'll have vectors A, B, and E, which are passing at a common point, which is the point of origin. Okay. Another noticeable set of vectors that are concurrent would be your vector C and D. So they are concurrent at this point. Okay. Next, do we still have any other concurrent vectors in the diagram? So there's still remaining set of vectors. So we have now GB. So why is vectors G and B concurrent? They are not naman intersecting. So if I will now extend vector G, or the line of action of vector G, until it reaches point 1, we can see that we will be intersecting at this point. So meaning, vectors B and vector G are concurrent at point 1, or the point of concurrence is point 1. Okay? So, it means, hindi sila nag-intersect, they will now not be considered as concurrent. So, we always look at the extensions of our vectors, especially for forces. So, here, you can see the extension. So, if I extend this, they are passing at a common point. So, another one, obviously, we have points or vector E and F, which is now concurrent at this point. So this is point 2. Okay. So next one, we'll have vector A and D. So same as for GB, if I extend now vector D at this, towards this direction. Okay. So we can see that they are concurrent at point 3. Okay. So if I'm going to do the same thing at C, and it will now intersect vector F. So are they now concurrent? No, they are not concurrent, as vector C is on your YZ plane and F is in your XZ plane. Mukha lang siyang nag-intersect, pero pag titignan natin siya spatially, hindi sila nag-intersect. Okay? So, however, your vector C and vector F could be concurrent if now our vector F will instead be positioned at point 4. Okay? So, kung nandito na siya. So, kung dito nakalagay siya, so nasa plane XZ pa rin siya, pero tatama siya dito sa point 4, in which C will also tatama, then FC will become concurrent. But in this case, they will not be concurrent. Okay, so let's move to the next one. Okay, so since vectors now are measurements or quantities that define our matter or our object, we may apply now different operations on our vectors. So the first one is your vector addition. So basically, there are two classifications on how we add our vectors. The first one is what we call your graphical method, and the other one is the analytical method. So under the graphical method, we have two methods under this one. The first one is your parallelogram method and your polygon method. For the analytical method, we have now three under this one. The first one is your algebraic method, the triangle method, and lastly, we have your component method. So when adding now our vectors, we have what we call your resultant, which is now the sum of your vectors, or the result of the combination of a set of vectors or of several. So let's start off with the first method, which is the algebraic method. So this is one of the simplest method, and we can apply it to any number of vectors as long as they would follow this condition. So they should be collinear vectors. If they are non-collinear, then we could not apply our algebraic method. So to understand this, let's have an example. So for the given vectors, A, which is 3 meters in the direction of east, we have B, 4 meters to the west, and 5 meters to the south. So let's determine our resultant for this. So before that, we assign our sign conventions. So for A, that will be a positive value since east is along your positive x direction. B now is negative as it is along the negative y direction, and C is also negative since we have south along your y or negative y direction. So if I want to get now the resultant of AB, so that's simply A plus B. So algebraic, it means we have to include their algebraic sign. So with this one, we'll have now positive 3 meters plus negative 4 meters, and that will now be equivalent to negative 1 meter. So the negative 1, so they are along the horizontal or along your x-axis. So negative here would simply mean that the resultant is 1 meters to the west. Okay, so next example under the algebraic method. So determine the resultant for all of the vectors, the resultant for. So next, aside from the resultant, we solve for C minus D, and then we have D minus A minus B. So the following vectors will have A, 50 kilometers due east. We have B, which is 20 kilometers due west. C is 30 kilometers due west. D is 25 kilometers due east. E is 60 kilometers due west. So for A, the resultant of all these vectors now will be equal to 50 plus negative 20, since it's in the west, plus negative 30 west, plus positive 25, which is along the east, and that will also be, lastly, we have plus negative 60, which is also west. Okay, so with that, we simply add them up algebraically. So R now is equal to negative 35 kilometers, wherein the negative sign now would mean that our direction is along the west. So the answer, or final answer, will be 35, or the resultant is equal to 35 kilometers due west. So next we have C minus D. So in here, we simply apply the operation. So vector C is 30 kilometers due west, so that's negative 30 kilometers. So we subtract now D, which is 25 kilometers, and it's a positive value since it is along the east. So apply now, simply apply your algebra. So C minus D is now equal to negative 55 kilometers, or that's also equivalent to 55 kilometers due west. So okay, for the next method, we have your parallelogram method. This method now is only applicable for 2 vectors. We cannot apply your parallelogram method if we have more than 2 vectors. So in here, the diagonal of our parallelogram will represent now either the resultant or the equilibrant of our set of vectors. So it depends on the direction now of our diagonal. So I'll show you later on how to identify if our diagonal is a resultant or an equilibrant. So we have here the word equilibrant. So what is its difference with the resultant? When we say equilibrant, it is simply a vector which will have the same magnitude as our resultant, but it will have the opposite direction. So for example, if the resultant is 5 meters east, then the equilibrant will be 5 meters, but it is now in the direction of west. Okay, so same magnitude but opposite in direction. And aside from this definition, an equilibrant will simply be a vector which, when we add it to the set of vectors, the resultant now will be equivalent to 0. So it's from the word equal, it will balance our set of vectors. So when we say balance, basically it's the resultant is equivalent to 0. So for example, I will have vector A is 2, vector B is 3, so the resultant is 5. So what is that value in which if I will add it to 2 and 3, it will give us a resultant equal to 5. So basically, that will be negative 5. So any value that would make our resultant equal to 0 is our equilibrant. Okay, so let's have an example for the parallelogram method. So determine the resultant for the given vectors. A is 15 kilometers, 33 degrees north of east, and we have B, 10 kilometers, 27 degrees south of east. So what we will do is to first draw our vectors in a scale. So I'll have this scale. So 1 unit is now equal to 5 kilometers. So this length now is equivalent to 1 unit, which is now equal to 5 kilometers. So if you're going to do this in your paper, you can have your scale as 1 unit is to 5 cm, depending on your paper. So I believe scaling has already been taught to you in your drawing classes. So let's start up first with vector A. So I'll start here, my point. So I'll have 15 kilometers, okay, 30 degrees north of east. So as we have said, this direction now is from east. You measure 30 degrees to the north. Okay, so this is 33 degrees. So we have 15 kilometers. So I'll have 3 like this. So we'll have 5, 10, 15. Okay, so next I'll draw vector B on the same origin. So that's 10 kilometers, 27 degrees south of east. So this will be my vector B. So this is south of east. So from east, I measure 27 degrees. It's 33. North of east. Okay, this is 33, this is 27. So this one now is 1 unit equivalent to 5, another unit equivalent to 5. So this whole length is equivalent to 10 kilometers. So it represents vector B. So next step is to simply draw now or form a parallelogram based on your two vectors. As a definition of parallelogram, this will have two sides being parallel. So I'll have here parallel of A, so that's A prime. I'll have here parallel of B, I'll call this B prime. So we already have here your parallelogram. And then once you have formed your parallelogram, what we will do is to connect now or draw our diagonal, and the diagonal will now be measured from the point or drawn from the point of origin, common point of origin, to the intersection of our parallel lines. So this is our diagonal. Okay, so if I'm going to measure now, that will be 1 unit, 2 units, 3 units, 4 units, and certain value. So that's now equivalent to 4.32 units. So since we have here your scale 5 kilometers, so with that, we just multiply this one. So 4.32 units will give us an equivalent of 21.6 kilometers, 10 degrees north of east. So where did I get this 10 degrees north of east? So I'll just simply measure our diagonal from our horizontal. So that is now, this one is 10 degrees if you're going to measure this one. Okay, so the difference now for the resultant if I will draw my diagonal from the point of origin to this intersection, this is my resultant. Okay? But if I'm going to draw our diagonal from the intersection towards our point of origin, then that will become our equilibrant, which is the same magnitude but will have the opposite direction. So for the equilibrant of this problem, it will be 21.6 kilometers, 10 degrees south of. Okay, so let's solve another example for the parallelogram method. So for this problem, we are now to determine the equilibrant of the given vector A, 3 meters, 30 degrees south of west, vector B, 4 meters, 40 degrees south of east. So again, first step, we start off or we draw our Cartesian plane. Identify your scale to be used if it's too big for us. So in this case, I'll be using this scale. So 1 unit is equal to 3, or the 1 unit now is equal to 1 meter. Okay? So this one, 1 meter or 1 unit is to 1 meter. So from here, I'll have to draw now vector E. So 30 degrees south of west. So from the west, you measure 30 degrees to the south. Then you measure 1, 2, 3 based on this scale. So this is vector A. Next, vector B. That's 40 degrees south of east. So from east, you measure 40 degrees going to the south. And you measure 4 units since it's 1:1. So we'll have 1, 2, 3, 4. And then once you have drawn your two vectors, form your parallelogram. So we have here A prime, then we have here B prime. So once we have drawn our parallelogram, next is to connect our diagonal. So we'll have our diagonal. So from our origin to our intersection. Okay? But since we're solving for our equilibrant, then it should be pointed towards our point of origin. So for our equilibrant, we simply measure now this line using our scale. So we'll have 1, 2, 3 point something. So we'll have 1, 2, 3, 4.11 now. So 1:1 meters. Then you measure it from this point. So from the west, that's 82 degrees going to north. So that's your equilibrant. Okay. So you can redo this in your free time and then compare if you'll have the same or almost the same values. So basically, for the parallelogram method, if you're going to do this in your own, there will be some discrepancies as there are some, or the discrepancy will be caused by the measurements. So baka nag-slide yung ruler ninyo while drawing the lines, or mali yung pagkakamark ninyo. Pero usually minimal lang naman yung magiging discrepancy natin. Okay, next method is the polygon method, which is another graphical method in vector addition. So unlike the parallelogram method, which can only be used using two vectors, for the polygon method, we can use this for 2 or more vectors. And it's also known or called as the tip-to-tail or the head-to-tail method. Why is it called tip-to-tail method? Since we are simply connecting our vectors from its tip to the tail. So basically, this is used for non-collinear vectors, but we have to note that this vector should be coplanar. Okay, so you have already learned what is collinear and coplanar. So to understand this, let's solve an example. So let's determine the equilibrant of the given vectors. So let's have vector A, 15 kilometers, 33 degrees north of east. We have B, 10 kilometers, 27 degrees south of east. So I'll use the same scale. So if you would notice, this is the same values of the first example in the parallelogram method. So let's check if they'll have the same result or same value. So I'll use the same scale here. So what I will do first is to draw our first vector using our EnggPhys scale. So we'll have 1:5. So I'll have here vector A, so north of east. So from east, that's 33 degrees. Measure now based on our unit. So 5, 10, 15 kilometers. So sa parallelogram, mag-start ako kung saan din nag-start yung vector A. Pero sa polygon method, mag-i-start ako kung saan yung tip ng ating first vector. So I will be starting at this point. And then that's the time I will draw my vector B, or my second vector. So this will be 27 degrees south of east. Then we measure 5, 10 kilometers. Okay? So once you have drawn all your vectors, you close it now in order to form a polygon. So resultant if it's from the origin, equilibrant if it's towards the origin. So we are directing it towards the origin since we are solving for the equilibrant. So final step, we measure your length, and for this problem we'll have now 4.3 units. So that's equivalent to 1 unit is to 5 kilometers. So we simply multiply it by 5 kilometers. So we'll have here a value of 21.5 kilometers. And you measure now this angle, that's 10 degrees south of west. So if you're going to check the parallelogram method, it's almost the same as this one. Okay. Next example for polygon method. So determine the magnitude and direction of the resultant for the given vectors. So let's have A, 2 kilometers per hour, 45 degrees north of east. B is 2.8 kilometers per hour, 58 degrees east of south. C is 5.1 kilometers per hour, west, 28 degrees south. And D is 3.2 kilometers per hour, north, 18 degrees west. Okay. So I'll have first vector A. So identify first your scale and then draw your first vector. So we have 2 kph, that's 45 degrees north of east. So I'll start at this point for vector B. So that is east of south. So from the south, we measure 50 degrees. And then towards this one. So if I'm going to measure using your selected scale, this will now be 2.8. And then start at this point again. We'll have vector C, which is 5.1. And it's west 28 degrees. So meaning from the west, measure 28 degrees going to south. And then we have vector D, which is 3.2 kilometers per hour north. So from north, 18 degrees going to the west. So we have drawn all our vectors. We now close our polygon. And since it's the resultant, we now draw it from the origin to the last vector. Okay? So I'll be measuring at the start already. Okay? So with that, using our selected scale, we now have 1.8 kilometers, and then measuring it from the west is 20 degrees north of west. So if I'm going to write for the equilibrant, that's simply 1.8 kilometers, 20 degrees, but it is now directed south of east. So next, we have your triangle method. So the triangle method is an algebraic method. So it's only applicable for two vectors. So why 2 vectors but triangle has 3 sides? So the third side of our triangle will be our resultant or your equilibrium. So depending on the form triangle of your vectors and the resultant, we will now use the following formula. So if it's forming a right angle, we now use your Pythagorean theorem. So if this is my first vector, second vector, and our resultant, then we use your Pythagorean. Or if we have now a triangle like this, so we have an acute and obtuse angles, we now use your sine and cosine laws. So for sine law, we have A over sine A equals B over sine B equal to C sine of C. Then for our cosine law, that's A squared plus B squared plus C squared minus 2 BC cosine of A. So you're familiar with this already from your trigonometry. Okay? So to understand triangle method, let's solve an example. So for the given vectors, let's solve our resultant. So let's use the same example as for the parallelogram method. Example number 1. So we have 15 kilometers, 30 degrees north of east. B is 10 kilometers, 27 degrees south of east. So for us, or to help us with our analysis, we can draw our triangle method. But when drawing your triangles for the triangle method, we follow the tip to tail. Okay, we connect our vectors. So we have here your 15 kilometers. So no need to scale it. Okay? Kasi math nang gagamitin natin, hindi na graphical. So kahit hindi sakto, approximation na lang. So we have 15 kilometers, and then for B, we'll have 10 kilometers. So we have here our triangle. Okay? So before we could identify which formula we could use, we have to identify first our interior angles. So we have north of east. So from east to north, 33 degrees. So this one is also 33 degrees. And then we have 27 degrees south of east is this angle. So the interior angle now between the two given vectors is theta. And we can solve theta now simply as 180 minus 33 minus 27, which will give us a value of 120 degrees. Okay? So since the angle formed by the two given vectors is not a 90 degree or a right angle, then we will now use your sine and cosine laws. So with that, I'll have now this angle as phi, and I'll have now r squared, which is unknown, is now equal to 15 squared plus 10 squared minus 2 times 15 times 10 cosine of the angle opposite our resultant, which is 120. And it will give us a value of 475 square kilometers. So the r now is equal to 21.79 kilometers. So for its direction, I'll be using this angle phi. So I'll be using the angle from our origin. So how will I identify that? I'll be using now our sine law. So we have sine is equal to 120 divided by r. So since alam ko ito, na-solve natin ito. So opposite of phi is 10. So phi now can be solved as 23 degrees 41 minutes. Or, so ito lang yon, okay? So hindi pa ito yung ating final angle. Kasi ang mini-measure natin na angle is the angle between this blue line representing the resultant and the angle between the horizontal. So what will I do? Ano ba tong value na ito? So that will simply be the angle between vector A minus phi. So graphically na yun. So that will now be 33 minus 23.41, which will give us 9.59 degrees. So therefore, the resultant of vector A and B using triangle method is 21.79 kilometers, 9.59 north of east. Okay? From the parallelogram method, the answer was 21.6 kilometers, 10 degrees north of east, which is very near our computed value. So which is more accurate? It is the triangle method. Okay? So mas accurate ang triangle method compared sa parallelogram or sa polygon method. Okay? So next we have the last method for our vector addition, which is component method. This one is the most accurate method for adding our vectors. So this is applied for any number of vectors. So it could be applied for 2 or more. Okay? So this is applicable only if the vectors are non-collinear. So how do we perform now addition by component method? So basically, we have here your vector A. So any vector. So it will have a magnitude and a direction. So this vector now can be divided into components. So we have what we call your AX, or the X component along your horizontal or X-axis. And then we have your y component, or your AY for this matter. So it's along our y-axis, or the vertical direction. So in here, as you can see, we can now form a triangle in terms of our AX and our AY, or our X and Y components. So with this, we can now compute for our X and Y components. So if our angle is measured from the horizontal, so let's call this theta, then our AX, or our X component, now can be computed simply as the magnitude of the vector times the cosine of the angle between the horizontal and your vector, or simply theta. And then for our y component, that will now be equivalent to the magnitude of a sine of theta. Okay, so it's simply trigonometry here. Okay, and then if our angle now is measured from the vertical, so let's call this angle phi. So the angle between your given vector and the vertical now is phi. Then our x component now will be computed as a sine of theta, or the magnitude of the vector, times the sine of phi, and then we have for your y component, that will now be equivalent to a, or magnitude of the vector, cosine of phi. Okay, so that is if the given is the direction and the magnitude of your vector. So what if we are given already, or instead, or the x and y components? So for that matter, for the magnitude, we simply apply our Pythagorean theorem. So the magnitude now of your vector is equal to the square root of your x component squared plus y component squared. Okay, and for our direction, so we'll just simply apply our tangent function. So theta now is equal to the inverse tangent of y component divided by your x component. And if we want it to be measured on the vertical, or from the vertical, then phi now is computed as the inverse tangent of the x component divided by your y component. Okay, but for us to be uniform, let us always measure our angles from the horizontal, para konti na lang yung ating i-memorize, or konti na lang yung formulas na kailangan nating tandaan. So that is now, if we'll be consistent that our angles will be measured from the horizontal, then we'll have now x component as a cosine theta and y component as a sine of theta. And for our direction, that's simply inverse tan, or arctan of y over x. Okay, and then you apply your north of east, south of east, or north of west, or south of west, depending on the direction. Okay, so to understand component method, let us solve an example. So let's determine the resultant for the given vector, which is taken from example 1 of our parallelogram method. So we were given vector A at 15 kilometers, 33 degrees north of east, and vector B is 10 kilometers, 27 degrees south of east. So in here, we can get or compute for our x and y components separately. So for vector A, so we know this is now 15 kilometers, 33 degrees. So we have your AX and your AY. So, or the x component of A and the y component of y. So for AX, that's now equal to 15 cosine of 33, as we know that this angle is 33. Okay, so computing AX now is equivalent to 12.58 kilometers. And then for AY, that will now be computed as, since the angle is taken from the horizontal, that's equal now to 15 sine of 33. And computing this from your calculators, AY now is equivalent to 8.17 kilometers. Okay? And then we move on to our next vector, B. So for vector B, it will also have its x component and its y component. So for EX, it's again measured from the horizontal south of east. So this one is 27 degrees. EX now is equivalent to 10 cosine of 27, giving us a value of 8.91 kilometers. And for AY, that will now be computed as 10 sine of 27, equivalent to the value of 4.54 kilometers. And this value should be a negative value. Why negative? Since our y component or the vertical component of B is along the south, which is the same as our negative y. So for this way of computing, we will have to check our sign conventions. So for EX, it's in the east, so it should be positive. Okay, correct. And then for AY, it's along the north, so it's positive, correct? EX is on the east, so it should be positive. So AY, pag kinompute natin siya simply as 10 sine 27, ang lalabas lang dito is 4.54 kilometers without any signs. So you have to check. It's south, kaya kailangang negative. Okay, so don't forget that. So, okay. With this, once we have computed for our x and y components for all of our vectors A and B, we can now compute for the magnitude of the resultant. So first, we compute for your Rx resultant of the x component by simply adding up our x components, Ax and Bx. So that is now 12.58 plus 8.91. So we have 21.49. It's a positive value. So therefore, its direction is in the east. And then for Ry, the resultant in the y direction, so we'll have Ay plus By. So we have now 8.7 plus negative 4.54. So it will give us a value of 3.63 kilometers. And it's a positive value, so its direction now is in the north direction. So this is not our final answer, since for the resultant, as I have said, if we're given the x and y components, we'll now apply our Pythagorean theorem. So R now is equal to Rx squared plus Ry squared, or the resultant or magnitude of the resultant is equal to 21.79 kilometers. So we're not yet finished because we still have to compute for the direction of our resultant. So for our direction, so ang sabi natin, we want to be consistent. We measure our angle from the horizontal. So for the direction, we'll now use arctangent of Ry over Rx. So we just simply substitute your Rx and Ry in this equation. So theta now is equal to 9.59 degrees. And since it's from the horizontal, that will now be north of east. Okay? So from our example 1, using parallelogram method, we have 21.610 degrees. And then we have from the triangle method, it was 21.75, 9.59. North of east. So if you can see, the triangle method and the component method would give us almost exactly the same value. So there would be some discrepancies now between triangle and component method depending on our rounding off. So dito sa parallelogram, medyo malapit siya doon sa mas accurate na value. So medyo accurate na tayo sa graphical method natin. Okay? So let's solve another example to further understand component method. So let's determine the magnitude and direction of the resultant for the given vectors from the example number 2 of polygon method. So the given vectors were A, 2 kph, 45 degrees north of east. Vector B is 2.8 kph, 58 degrees east of south. C is 5.1 kph west, 28 degrees south, and D is 3.2 kph north, 18 degrees west. So instead of me individually computing for the x and y components, kagaya nung sa first example natin, para mas maayos, mas madali natin siyang i-compute, we could use a tabular form. So in this sense, we'll have now the first column as our vector. So the next column is the magnitude, followed by the angle made by the vector from the horizontal. Then we have here your x component. So since our angle is measured from the horizontal, x component now is equal to a cosine of theta. And for our y component, that will now be equivalent to a sine of theta. So for our vectors, we have 4. So we have vector A having a magnitude of 2 kph and its angle now from the horizontal. So from the east, so it's the horizontal, our angle is 45 degrees. Okay, next we have vector B, which is 2.8 kph. So in here, we will not use 58 degrees, okay, since we want our angle to be from the horizontal. So dito sa vector B, yung 58 degrees is from the south, which is your vertical. So for our angle, that will now be 90 minus 58. Next, we have vector C, which is 5.1 kph in magnitude. So in this vector, the direction is from the west. So that's your horizontal. So we simply use 28. And then for vector D, we have the magnitude 3.2. And our angle is measured from the north. Okay. So meaning, I'll have to compute for theta as 90 minus 18. Okay, with that, we can now compute for our x and y components. So let's compute first for our x components. So for vector A, x component now is equal to 2 cosine of 45, giving us a value of 1.414 kph. And then we have for B, that will now be 2.8 cosine of 32. So that's 90 minus 58 is 32. So if we're going to compute this, input this in our calculators, this will give us a value of 2.374 kph. For vector C, that is now 5.1 cosine of 28, giving us a value of 4.503 kph. And for vector D, that is now 3.2 kph cosine of 72, equivalent to 0.989 kph. So as you can see, all our values are positive values. But if we're going to check our vectors, we have now east and west directions. So we have to check this one. So for vector A, it's in the east direction, so it is a positive value. B is east, so that's also positive. C is west, so that should be negative. And D is also in the west, so that should be negative. Okay? So whenever we measure our angles from the horizontal or the vertical, we always make sure that we check the sign conventions of our x and y components. Okay, so next step, we compute now for your y component using this equation. So for A, that will now be 2 sine of 45. So that's equal to 1.414 kph. B is 2.8 sine of 32. So that will be equivalent to 1.484 kph. C, y now is equal to 5.1 sine of 28, which is equal to 2.394 kph, and dy, or y component of d, is 3.2 sine of 72, giving us a value of 3.043 kph. So again, we check our sign conventions. Vector A is north, so that should be positive. Vector B is south, so that should be negative. C is south, so that is negative, and D is north, so that should be positive. So once we have computed all of our x and y components, we now compute for our sum of the components. So for x component, Rx now is equal to negative 1.704. So we add it up together with the sign convention. So the negative sign here demonstrates that Rx is in the west direction. And then for our y component, add them algebraically together with their sign conventions. So Ry now is equal to positive 0.79 kph. So the positive sign for this value represents that we are in the positive y direction, which is our north. Okay, so once we have computed for your Rx and Ry, we can now solve for our magnitude. So for the magnitude, it's now equal to the Pythagorean theorem, Rx squared plus Ry squared, and take the square root. So this will give us a value of R equal to 1.799 kph. And for our direction, since we are in the horizontal, or our reference is the horizontal, so the direction now is equal to the arctangent of Ry divided by Rx, or theta is equal to 18.767 degrees north of west. So if we're going to compare our computed answer using the component method to our answer from the polygon method, that was 1.8 kilometers or kph, and that is 20 degrees north of west. So we have 1.8 versus 1.799, and we have 20 versus 18.767. So they're almost the same, but it's more accurate, or the more accurate answer is from our component method. So okay, let's solve another example for component method. So determine the magnitude and direction of the resultant for the given vectors. So we have vector A, 17 newtons, 83 degrees north of east. B is 44 newtons, 13 degrees east of south. C is 25 newtons, 74 degrees west of south. D is 30 newtons, 43 degrees west of north. And lastly, we have 32 newtons due north for vector E. So let's use again our tabular form in our solution. So we have vector, we have the magnitude. So we'll have here our angle. So as you can see, this is from the east already. In the previous problem, we have our angles measured from either east or south. For this problem, we'll only be having one reference, which is our east, or the 0-degree reference. Okay, so next we have your x component, which is equivalent to the magnitude cosine of theta, and y component is equal now to the magnitude times your sine theta. So we start off first with vector A with magnitude 17 newtons. So its angle from the east will be equivalent to 83 degrees. Then we have vector B, which is 44 newtons. Its angle now is 13 degrees east of south. So it means that from the south, we move 13 degrees towards the east, or that's equivalent to 270 degrees plus 13. Next, we have vector C, which is 25 newtons. So its direction is 74 degrees west of south, or that means from the south, we move 74 degrees to the west, or that is now computed as 270 minus 74. Next, we have vector D, which is 30 newtons. Its direction is 40 degrees west of north, or it means from the north, we move 43 degrees to the west, so that will now be equivalent to 90 plus 43. Lastly, we have vector E, which is 32 newtons in magnitude, and the angle now will be equivalent to 90 degrees as the direction is due north. So once we have now identified our angles measured from the east, then we'll have our x and y components. So let's start off first with the x component. So ax, that's now equal to 17 cosine of 83, giving us a value of positive 2.072 newtons. Bx will now be 44 cosine of 283, and that's equal to positive 9.898. Cx is 25 cosine of 196, equal to negative 24.031. Vector dx is now equal to 30 cosine 133, equal to negative 20.460. And ex is 32 cosine of 90 equal to 0. So if you have observed, in our values now using the angles measured from the east, there is already an included sign convention. So if we're going to check, ax is positive since it's along the east direction. Bx is also in the east, that's why it is a positive value. C is a negative value. Is it in the west direction? Yes, so it's correct. And then we have D is in the negative direction, so it's also in the west. Okay, so if you're going to compare this later on, if instead of using angles from the east, but I'll have it based from the angles, ang difference lang nung measured from the east and measured from either east or west is that in our previous problem, nag-compute muna tayo ng values ng x and y components. Saka natin chinek kung ano yung sign conventions depending on the direction. Dito naman, because we have established that our start is the east, which is your 0 degrees, nabibigay na niya kung ano yung equivalent directions or yung equivalent sign conventions ng ating direction for the x component as well as for your y component. So let's check it later on. Okay, so let's move for the y component. That will now be 17 sine 83, and that will give us positive 16.873. B, y is 44 sine of 283 equal to negative 42.872. Cy is 25 sine of 196 equal to negative 6.891. dy is equal to 30 sine of 133, and that's equal to positive 21.941. And we have ey, which is equal to 32 sine of 90 equal to positive 32. So if we're going to check again, A is in the north, that's why it's positive y. B is in the south, that's why it's negative here. C is in the south, so it's negative. D is north, that's why it's positive. E is north, that's why it's positive. Okay, so it's up to you if you want to use the method or the process in the previous problem or this process. Okay, so any will do. Just remember that if you're going to measure it either east or west, you have to check your sign conventions. Hindi lang yung diretsong sagot. Okay? Pag gagamitin naman natin is angle from the east, you have to make sure that your angles or computation of the angles is correct in order for us to give or compute for the correct value and the correct sign convention. Okay? So, then, once we have now computed for your x and y components, we can now compute for your total x and y. So, for our rx, just simply add this up, and it will give us negative 32.521, wherein negative for the x is equivalent to the west direction. So, for our y, simply add this up. Ry now is equal to positive 21.051, wherein the positive is equal to the north. Okay? So with that, given now Rx and Ry, we can now compute for our resultant, which is equal to the square root of Rx squared plus Ry squared. in which R now is equivalent to 38.740 newtons. And for our angle, the angle now is equal to the arctangent of Ry divided by Rx, and that will give us a value of 32.915 degrees, and that is north of west. Okay, so that's it for vector addition. Okay, so to understand unit vectors, let's have an simple example. Okay, so let's say we have vector A, which is denoted as 3i plus 4j minus 5k. So, di ba, sa 2 dimension, sinasabi lang natin siya as north of east. So, para lang siyang I and j. Dito meron ng kasamang k, or meron ng z-axis. So, to represent this one, or to better see how vector A will look like, so let's have our 3 axes, so x, y, z. So, we have here 3i, so it means we have 3 units to the I is equivalent to the x-axis. Okay, so it means we have 3 units along the x-axis. It's a positive value, so meaning we have to go to the positive direction. So with this, I will have now 1, 2, 3. So this is 3i, or it simply means 3 units to the positive x direction. Okay. Next, we have 4g. So what does it mean? I have 4 units, so g, it is along the y direction, and it is a positive value. So it means I have to move to the positive y. So I'll have now, so from this point, that will now be 1, 2, 3, 4. So this is our 4j. Okay. So next, we have 5k. So k is in the y direction. So therefore, we'll have 5 units along the y direction, but is a negative value. So meaning we have to move to the negative side or negative direction of z. And that is now along this direction. So I'll have 1, 2, 3, 4, and 5. So this is now 3i, 4j, negative 5k. Or vector A now is this line. It is along this space. Okay? So next, another example. para mas maintindihan pa natin. We have b, which is equal to negative 2i minus 3j plus 2k. So with this, I'll have now negative 2i, meaning I am moving to the negative I or negative x in 2 units. So that is 1, 2. Negative 3j, so it means it's along the negative y direction with 3 units. So that is 1, 2, 3. And I'll have positive 2k, or that's in the positive z direction with 2 units. So that's 1 and 2. So with that, I'll have now vector b as this one. Okay, so if we can see, vector A now is in the positive x, y, negative z space, while B is in the negative y, negative x, negative y, positive z space. Okay, so that's how we interpret our unit vectors. Okay, okay, so same as for our two-dimensional vectors, we could also apply our addition and subtraction for our unit vectors or our spatial vectors. Okay? So, to have a grip of how we add or subtract our vectors in unit vector notation, let's solve an example. So, we're given vector A, which is 3i plus 4j minus 5k. We have vector b, which is negative 2i minus 3j plus 2k. So let's solve. Let's call the sum of the vectors as c, which is a plus b. So what I will do, I'll just simply add them up. So that will be 3i plus negative 2i plus 4j plus negative 3j plus negative 5k plus 2k. So ang i-add ko lang dito are those terms having the same unit vectors. So, ang i-add ko lang is I plus I, J plus J, K plus K. Hindi ako pwedeng mag-add ng I plus J or J plus K and the like. Okay? So, with that, I lang ang magkasama. So, our answer now will be equivalent to, or A plus B, which is equal to vector C, is now equal to I, since 3 minus 2 is 1. So, 4 minus 3 is 1, so that's J. So, no need to write number 1 here. So it's understood already that this is 1 unit. So negative 5 plus 2 is negative 3k. Okay? So another example. So let's determine the vector difference for the given vector. So let's have the same value for A and B. So let's call the difference as D. So that's A minus B. Same process. Ang ima-minus ko lang is, or isusubtract ko lang, will be those having the same unit vectors. So that will be 3i minus negative 2 minus or plus 4j minus negative 3 plus negative 5k minus 2k. So that will give us now the difference as, so 3 minus negative 2 is 5i, 4j minus negative 3 is positive 7j, and then we have negative 5 minus 2 is equal to 7k. Okay? So the next operation that we use or perform to our vectors is what we call our vector multiplication. So this is more applicable for the unit vectors or our spatial vectors instead of the two-dimensional ones. Okay, so there are actually two ways of multiplying the vectors. The first one is what we call the dot multiplication, which yields a scalar product. Okay, so for dot multiplication, we call the product as dot product or a scalar product. And this product now can either be a negative or a positive value depending on our outcome. So the general equation for our dot multiplication is given by this equation. So you have A dot B is equal to the magnitude of A times the magnitude of B cosine of theta. If we do not know the value of theta, okay, we can compute for A dot B in another way. So what we will do, so we have A dot B, we'll expand now our vectors. So in terms of the unit vectors, so we'll have AI, AJ, AK, dot BI, BJ, BK. So we simply distribute this one. So I'll have AI times BI, so times BJ times BK. So same, AJ is multiplied to BI, BJ, BK. We'll have AK is multiplied to BI, BJ, BK. So for dot products or dot multiplication, we note that when our unit vectors are in the same directions or are parallel, their values will be equivalent to 1. Okay? And if the vectors or the unit vectors are in the perpendicular directions, they will now be equivalent to 0. So that means if I will have now AX times I or AXI times BXI, then II is equal to 1. And then IJ, which is perpendicular to each other since X and Y axes are forming a 90-degree, then this value is equivalent to 0. Same goes, I times K is also equivalent to 0. So in simpler statement, A dot B is simply multiplying our unit vectors with its or our terms with the same unit vectors. So I times I lang siya, J times J, K times K lang siya. So parang doon sa addition, subtraction, na same unit vectors or terms with the same unit vectors lang ang i-deal natin. Okay? So to understand this, let's have an example. So ito yung sinasabi ko. Or before the example, ito yung sinasabi ko. If we have the same direction, so I dot I is 1, J dot J is 1, K dot K is also 1. So pag yung sa iba na, IJ is 0, JK is 0, IK is 0. Tapos baliktad nila, it's also 0. So therefore, simplifying it now, A dot B is simply equal to AX, so the value of that I, times the value of BI plus AY times BY plus AZ times BZ. So nawala na yung ibang terms ninyo. So there are no unit vectors in our final answer. There's no I, J, and K. So therefore, our value or our product is a scalar quantity. Okay, so for the next type of vector multiplication, we have what we call your cross multiplication. For this type now of multiplication, the product yielded is what we call a cross product or also known as a vector product, since our result will have a direction. Okay, so the cross product now of the two vectors will always be perpendicular to the plane of your two vectors that is multiplied. So how can we explain that? So let's imagine your x, y, z, and z axis. Okay, so if I'm going to multiply, or if the vector is along x and the other vector is along y, if I'm going to multiply them, x, y, their cross product now will be perpendicular to the both of them. So ano ba yung perpendicular sa x aside from y? That is z. Ano yung perpendicular sa y aside from x? That's also z. So therefore, the products now or cross product of x and y will be z. Okay? So to understand further, let's have this diagram. So if I will have now vector A and vector B having a an angle theta, okay? So not necessarily perpendicular. We'll have cross product is perpendicular to both A and B. So yun yung ibig niyang sabihin. So A and B does not necessarily need to be perpendicular, but their cross products must be perpendicular to the both of them. And as you can see, if I will have A cross B, which is pointing to the upwards, then yung kabaliktaran niya, B cross A, will now be pointing downwards. Or simply, A cross B is simply the negative of B cross A. Okay? So, parang ito yung resultant natin, ito naman yung equilibrant. They have the same magnitude but opposite directions. So, take note that for cross multiplication, for same directions or vectors having the which are parallel, they will always be equal to 0, unlike for the dot product. Okay? So, for cross multiplication, so pag parallel, I cross I, automatic, it's equivalent to 0. J cross J, it's also 0. K cross K is also 0. IJ will be equal to K. So, yung perpendicular nila. Next, JKI is equal to J, and JK is equal to I. Pag pinagbaliktad ko ito, negative K naman siya. So, IK will be negative J, and K cross J will be negative I. So, if we're going to expand our vectors, so A cross B, so expanding them into their unit vectors, I'll have AI, AJ, AK, BI, BJ, and BK. So, same. I'll distribute them. So, I will have now AXI, BXI. So, I'll have AI, BJ, AI, BK. So, next, I'll have AJBI, AJBY, AJBK. Next, AK naman, distribute natin. So, I'll have AKBI plus AKBJ and plus AKBK. So, II is 0, AJ or JJ is also 0, KK is also 0. So, ang matitira lang sa atin is ito. So, IJ is K, IK is J, JI is K, JK is I, KI is J, and KJ is I. Okay? So, for cross multiplication, basically, pag sinimplify natin yung kaninang equation natin, we'll have now AXBY times K minus AXBZ times J minus AYBX is K times K, AYBZI, AZBXJ minus AZBYI, or this will be our general equation. So, you don't have to memorize this as long as you know how to use your matrix. Mas madali na siyang isolve. So, okay, let's solve an example. So, let's have A dot B, B cross C, A cross C dot B. So, given now the following vectors, A, B, and C, let us solve for the required. So, the first one is A dot B. So, simplifying natin. So, that's equal now to 3i 4j minus 6k dot 4i minus 5j minus 5k. So, multiply ko lang yung pareho. So, that will now be 4i times, or 3i times 4i plus 4j times negative 5j. Tapos, negative 6k times negative k. Or our value now is equal to 12 minus 20 plus 16. Or plus 18. So, we'll have the value at 10. So, wala siyang IJK, kaya siya scalar. Okay? Alright, next, we have B cross C. So, for this one, B cross C, so we have 4i, 5j, 3k cross 2i minus 3j plus 2k. So, B cross C, matrix form ang gagawin ko. So, first column is I, yung values ng I. Yung second column ko is kung ano yung nauna. So, B is 4, C is 2. Followed by J. So, for B, that's negative 5. C is negative 3. Then, we have the next column, K. So, for B, that's negative 3. And for C is 2. So, kopyahin ko lang first column. And then, we do our matrix. So, we'll have first I times negative 5 times 2. So, that's negative 10I. Okay? So, diba, J times K is equal to I. So, next, we have J times negative 3K times 2I. So, we'll arrive at negative 6J. Then, we have negative 12K for this one. So, next, pataas naman. So, I'll have negative 10K, positive 9I, and positive 8J. So, this one now will be computed as negative 10I minus 6J minus 12K minus positive 9I plus 8J minus 10K. Or that is now equivalent to negative 19I minus 14J minus 2K. Okay, so that's it for Module 1 vectors. So I hope you have learned or have additional knowledge based on your readings of Module 1. So if the examples are kulang, then there are more examples in the module. You can review them. Okay, so the activities for Module 1 will be uploaded in the classroom. Just wait for it. Okay, again, thank you for listening.